Hello everyone, my name's Devin. I'm an engineer at Airbnb, and I'm going to be talking about design tools and React. So for the purposes of this talk, I want to take a look at the future of React. That could mean a lot of different things. It could mean suspense or React Native DOM. It could mean Reason React or any number of other things. But I want to look beyond any specific platform or implementation or API. I'm going to start with a question. Has anyone ever asked you this? You don't have to raise your hands. Should we use React Native? I get asked that a lot, like multiple times per day sometimes. Companies of all sizes, small and large, engineers who have web backgrounds, native backgrounds, backend engineers, everyone's wondering, should we use React Native? And while React Native offers a lot of benefits, it's still a fairly big decision because it can mean a completely different tech stack, ramp up time for your team. If you're writing an existing app and integrating React Native, it can mean you have both native and React Native code now to maintain. It can mean hiring different kinds of engineers, and it can mean some platform lock-in. So if you switch to it, it can be hard to switch off. Now that's not to say you shouldn't do it, of course, but it is like a big question to think about. So how can we make React easier to adopt on other platforms? And I want the answer to, should I use React, to be yes all the time. So how do we make that happen? And I'm going to try to answer this question because I think this will really shape the React of the future. So let's look at some existing strategies for taking React to other platforms. I put React star because even things that are sort of React-like, I would sort of consider in the same category. So anything that's like a declarative UI framework. So React Native, the strategy there is let's embed a JavaScript engine, you write React. Electron, let's embed a web browser, you write React. Component Kit, this one's a bit different. So if you're not familiar with it, this is a Vue framework for iOS based on React. So it's essentially the React component API, but native for iOS. And then moving even further from React, we've got Flutter, which is let's rewrite the UI layer from the ground up to be the same on multiple platforms. And if you really wanted to write React, you could imagine a React Flutter pretty easily. But maybe there's a better way. Is there a way we can bring React to any platform but without a library or framework? Because that would make it really, really easy to adopt. Then it would be a much smaller decision for teams. So, okay, let's say we want to bring React to another platform without a library or framework. What's the essence of React that we need to bring over? I'd say it's really two things. First, it's declarative components, and second, it's unidirectional data flow. So declarative components, the idea that the same input props will always give you the exact same UI when rendered. And unidirectional data flow, this isn't strictly a React component thing, but our React components need to support it. So they can't store any state. Even input elements, they can't be the source of truth for our state. The state always has to be controlled by a parent. So let's decouple these patterns from the framework. Let's take declarative components and unidirectional data flow and sort of extract them out. What if we could write declarative components on any platform without a library or framework? What if we could automatically transform React components into native components? Because suppose I have a component library. What I really want to do is I want to take this React component library and I want it to run on every platform, regardless of what library or framework or language or platform. I just want it to work. I want to write React and I want it to work everywhere. If that's a bit abstract, let me hop to a quick demo to illustrate the point. So in this demo, I have two code panes. On the left side, I have a React Native code pane, and on the right, I have Swift. And this is a native Swift component using UIKit and rendering UI views. And I'm going to demonstrate how I can translate a React Native component into a native Swift component. So over here on the left, I'm going to start writing some prop types. So let's add a title. And you can see on the right, my Swift component has been updated to reflect what I've added to React. So we can see I've added a title to the initializer, which is essentially just the constructor. And I've added this public variable called title. And you'll notice that each time, both when I initialize, I call update, and if I change the public variable, I call update. And the reason that's important is because that's what lets us preserve this declarative component guarantee. Anytime the inputs change, we update the UI to always look exactly the same based on the inputs. So let me add a little bit more. Let's add a subtitle. We can see another input parameter has been added. That's not too complicated. Let's go down here, and in the style, let's add a color. Also pretty simple. If we add a color red, we can see it's automatically translated into a color literal in Swift. Okay, now it gets more interesting when we start thinking about subviews and layout. So I'm going to add another, well, actually first I'm going to add a bit of layout. So I'm going to say I want a width in this component. So I added a width of 1, and over on the Swift side, you can see I'm actually translating the flexbox layout into auto layout constraints. So we can see I'm setting up a constraint on the width anchor. And if you're not familiar with Swift, that's totally fine. But the point is, I can translate a subset, and a pretty big subset of Flexbox, directly to the native Swift layout implementation. The main thing I can't translate is flex wrap, but I find that that is mostly used for grids in practice, and there are other ways we can do grids. So let me keep going. I'll add another view here. I'm going to give it a special prop called ID, which will just set its name. And you can see this sets up a bunch of boilerplate. Some of it we could get rid of, but at Airbnb we expose a lot of properties so that we can customize style. And it actually generates a lot of layout constraints to imitate Flexbox. But this is pretty powerful because this layout is extremely performant. Humans often won't write layout constraints like this. They'll use stack views because it's easier, but this is much faster. So that's how we want it at Airbnb. Anyway, in this demo, I showed you how I can take a React Native component and translate it into Swift, which is pretty cool. Now what's actually happening here is I'm going through an intermediate format. So I'm taking my React component, I'm converting it first to a JSON format, which I'm calling .component, and then to Swift. And this is powerful because from the JSON, I can much more easily manipulate this component. And then I can turn it into any flavor of React, whether React DOM, React Native DOM, React Native Web, whatever, or Swift, or Component Kit, or Reason, or Flutter, or Vue, or really anything. And that's my goal. I want to make learn once, write anywhere a reality, so that the same React component will run on any platform, in any language, with any framework. Thank you. Thank you. Okay, so how can we make React easier to adopt on other platforms? Well, I think this is a big part of the answer. I came up with this line, BYOF, bring your own framework. Let's not use that, but that's the idea. If you can use your existing tech stack without any changes, I think it would be significantly easier to start adopting React or React Native or any sort of React variant in your app. So today, React is a library for interpreting components at runtime. You don't know what your component looks like until it's been executed. But I believe in the future, React will be a data format for describing components at compile time. Maybe not all the time, but for a lot of use cases, this is extremely powerful, knowing exactly what your component looks like and being able to translate it into any language at compile time. So let me go into how it works before I show off some cool stuff. How does it work? I'm going to talk about 3 parts. First, what does the generated code look like? Second, what's the API for actually generating code? And third, what does that .component data format look like? For generated code, we need to preserve React's guarantees. So this is the declarative components and the unidirectional data flow. So if we look at how that might work, we really just need to make sure that our UI is a function of our state. Taking the Swift example further, we had that initializer where we is essentially the constructor, and we set the initial props, and then we call this update function. And then when we set the title or subtitle, we also, again, call the update function. And we just need to make sure in our update function, our UI always comes out looking exactly the same. Now, you could imagine, like React, our update function could return elements, it could do reconciliation, it could do all sorts of cool optimizations. I think that's definitely one option. In native iOS and Swift, it's often fast enough just to essentially flush to the DOM directly, just to update your UI views right away. And so it's not necessary that this is pure it can have side effects as long as the compiler guarantees that you always get the same UI from your state. So the other thing that we need to guarantee is unidirectional data flow. So for this, we might have, for example, a text input element, and it might have a title, and then when it changes, we call an onChange callback. The important thing here is, as the user types in the text input, we do not update the title. We send the parent the update through onChange, and the parent can decide what to do with that. So these are, of course, called controlled components. And I think this should be possible to do on every platform. Certainly React Native has shown us that it can happen on iOS and Android. And while not strictly necessary, for most apps, you're going to want to store your state at the top level, so this is important. Second, the API of this thing, we need to integrate into any code base. It's not really good enough if this is only for new apps or for simple apps. It's got to be for every app. And so I think about this in two cases. There's the greenfield case, which is a brand new app. The conventions and libraries haven't been determined yet. And so for that, we can sort of come up with something generic. So there's a CLI tool to generate components in a standard style, sort of community best practice for the platform or framework. The brownfield case, which is an existing app, is much more interesting because the patterns and conventions have already been defined for the app. So our generated code has to fit into that. And for this, there's an AST level API. So you really get to decide exactly what your generated code will look like. And we provide access to common algorithms. So you don't want to have to do a flexbox to auto layout conversion yourself. It's actually really complicated. But if you can just call into that, get an AST back, put that in your custom AST, it's not too bad. So using that, you can make your code look however you want and have it fit in perfectly with your existing code. Then the last thing, the data format for this. What makes a component, and how can we represent it as data? Well, couple things. Components have props, so input parameters. They have state. They have a render function, which is the render logic and the element hierarchy. And they have styles, flexbox layout, color, background, etc. So if we're going to turn this into a data format, let's just try writing it as JSON. A simple skeleton of this might look like this. Might be props, state, render, and styles. I'm going to make a few tweaks. So props is very React specific. I want to be thinking in terms of more cross-platform terms. So I'm going to rename this to params, but same concept. And then render and styles, these make sense as separate things when writing code manually as a human because you want to reuse styles, you want to optimize to have the fewest number of styles, you want to have your render function look really clean. But for a computer, the compiler doesn't really care about this, so I'm just going to combine them into one. So root, as in like the root element returned from your render function. This is the rough skeleton of .component.json. Let's look at each of these in a little more detail. If we look at the params, which is the props, we can see they have a name, a type, and a default value optionally, so pretty much prop types and default props. Similarly, state has name, type, and initial value. Root is more interesting. Here we need to represent the component type, whether it's host like div or view or Android view, or whether it's a composite component, one that you've written custom out of those. We need to represent props, styles and layouts, render logic, and children. And I'll give a rough high-level view of what that might be. So you can imagine we have a type for the component, params, which is the props. The compiler, again, doesn't really care if we group these in style and not style. It sees them all as sort of the same thing. And optionally, children. So using this approach, we now have a React component defined in JSON. And we might consider storing the JSON in our code base because we already have it, so why not use that as a source of truth? There are actually a couple problems with using JSON as a source of truth, all potentially avoidable, but JSON isn't very easy to merge, so you don't really want to try merging a UI represented as JSON, and it also isn't very easy to visualize a UI written as JSON. So I think it makes much more sense to have the sort of canonical universal component format be actually React Native. So be a statically analyzable subset of React Native that can then be converted one-to-one to that JSON format, which is exactly what I was doing in my demo earlier. So I was extracting the important info out of the JSON and then converting it into Swift. So with this approach, we now have a single source of truth. So regardless of how many platforms we have to support, all of our component definitions are in one format and one place. And this can both mean we have the same component running exactly the same on multiple platforms. It can also mean we're writing different components for iOS and Android, but just in the same format. And that's really, really powerful because this enables a new kind of development workflow. And now is when I introduce something that is already open source, and you already might have seen it, and I've been working on it for a while, but I've never actually spoken about it before. It's called Lona. So this is an open source project, and Lona is a React-based data format for defining components. Using this format, we can automatically generate native iOS, Android, and React implementations, or we can even load the component files directly from our apps at runtime, so just load the JSON over the air and render it out. And one of the most powerful things is we can mix and match with our existing components. So since these are just generating regular components for your platform, you can use one Lona component and one normal component interchangeably, which is very powerful. So if Lona isn't working out, there's no lock-in. You just take the generated output and remove the source React or .component files, and you don't use it anymore. But wait, there's more. Do you ever get tired of writing components? Do you ever get tired of writing components? I get tired of writing components, and there's got to be a better way. I mean, most of the time these things look pretty similar. I open up my text editor, view text image, I style them, maybe I have a sketch mock, I adjust the paddings and the margins look exactly the same. You might know what I'm getting at. Well, I think with Lona, React enables us to build components visually, and that's really the future of React. That's what we get from it. What if design and engineering tools both use this .component format or something like it? And to prove out how this might work, what the workflow might be, what the logistics of it would look like, I made an example editor called Lona Studio. I think there could definitely be multiple editors for this thing. It could be directly in your IDE, but let's take a look at Lona Studio. Lona Studio, I think of as a design tool for engineers and an engineering tool for designers. It's way more visual than you're probably used to from an IDE, and for a designer, it's way more powerful and constricted than you're used to from Sketch. But that's kind of what I think we need to usher in this future of building components visually. So component files are managed by both designers and engineers through Git. This is all open source. You can check it out. It's at Airbnb/Lona. It's very beta. Very beta. It's mostly written by me, like 99% me, plus some really, really awesome contributions from open source folks. But again, probably not for production. Now, if it's generating components and you're happy with the generated code, there's essentially no reason not to use it. So the bar is much lower for where it needs to be to use, but still, probably it's going to crash. Probably my demo is going to crash, but probably it's going to crash. So this comes in two parts. There's Lona Studio, which is written in Swift, which is a Mac app, and that's because all Airbnb designers and engineers have Macs. And I'd never written Swift before, so yeah. And then there's the Lona compiler, which takes the .component format that is output by Lona Studio and turns it into a different platform implementation. I'd also never written ReasonML before. Let's jump into the demo. Gonna reconfigure my screens here so it's a little easier. Cool. All right. This is Lona Studio. Lona Studio is an app that lets me build cross-platform UIs. So I, of course, made the React Europe app. It seems to be a theme here. So this is a native iOS version of the React Europe app. I mean, not the actual React Europe app, but like a ugly version that I remade in a couple hours. So if we open up the Lona workspace, we can see that all of the components that are used in the app are just React components that I'm rendering in these little cards. And so I can preview my whole app. And what to do first? Well, let's open button. And at its core, Lona is essentially a Flexbox builder. So I use different tools on the right to build out my components. And one of the cool things about it is it lets me preview on multiple screen sizes and with multiple configuration of props at once. So I can test, for example, what this button looks like on a wide screen or with a lot of text. I can make sure the wrapping works just right. And just as an example, let's change the background color. Now, I've pre-configured the colors for my workspace. So these are just constants. And this is really to facilitate working with design systems. So if we go back to this other window here, we can see I've sort of configured my design system, which can include colors, text styles, shadows, gradients, and data types. Data types are actually very important for design systems, but I won't go into that today. But anyway, back to my component here. Okay, so I changed the color. Let me add some text. I'll say, hello, React, you're up. I'll make the text white. I want it to actually spread to fill its parent, and I want to center it. And maybe I want some margin up top. Cool. Okay, so now I'm going to save that. And next, after I've changed the .component file, I'm going to go into the terminal here and run my Lona compiler to translate the workspace into Swift. If I hop over to Xcode, I can now see I have this generated directory. And from here, we have all of my React components now turned into Swift components. I also have this 20 lines of sort of boilerplate to set up the app. And let me just rerun that. So this is React, so I have to wait for, or this is Swift, so I have to wait for it to recompile. But you can see that the UI updated. So, yeah. Okay, so that's pretty cool. So I'm turning React components into Swift. But this is a React conference after all, so let's get a bit more React focused. So I have the same exact app. If I can, yeah, same exact app running in React Native. So this is a React Native app, but it's the exact same UI. Now, being React Native, I don't have to wait for it to recompile, which is very exciting. So when I change the color, for example, it updates right away. So I'll delete that. Let me run through a few more cool things. Okay, let's head back to the components list, and I'm going to edit this person card right here. So this one, and this one is used for this Brent Votney card, and I'm going to add a button to it that'll automatically take me to tweets or something. So I'm going to add layer. I can see the existing components in my workspace. I'll add a button. I could say, like, tweet about it. Cool. I'll add a little margin below my description. Great. Now when I save it, you'll see the tweet about it button pop in, which is pretty cool. If I go to this home component, normally you probably wouldn't have a whole screen as a component. You totally could, but you'd probably have it be populated with data more dynamically. But I'm going to clone or duplicate this section header and then drag it down. So this coming up next section down here, call it section header 2. And instead of saying coming up next, we'll say drinks. Cool. And now I'll duplicate the person card, add another one of those, save, and it, of course, gets updated, which is pretty cool. Let me show a couple other things. So because it's configured to work with my design system, if we want to do a rebrand of React Europe and we want to change the color, all I have to do is change it here in one place, and it updates everywhere in the app, which is pretty cool. And I can even then see it updated in all of my components at once without actually re-rendering or compiling anything, which is pretty cool. All right. I think that's enough for the demo. I'm amazed it didn't crash. So to wrap up here, why would we want to do this? Well, a bunch of reasons. Designers can iterate on designs without interfacing with engineers. I mean, in some cases, they'll definitely still have to, but we're both using the same components, so that's pretty easy. Cross-platform consistency, which is great for users. Optimal performance. We can compile to native Swift. We can compile to React Native. You could imagine compiling some things to native Swift. You could imagine generating the bridge to React Native automatically. You could imagine in the future if Flutter takes off, compiling to Flutter. I don't know. You could And so choosing a UI library or framework doesn't have to be this enormous decision. What if you could seamlessly just switch back and forth? And I also think it would be really amazing if the open source communities could help one another. Like, if we have a compiler that can generate code for any platform, why can't we have all the same optimizations happening for Swift, for Kotlin, for React, all of that stuff? And so I built this Lona Studio app largely as like here's what editing UI based on React should look like. But I think there should be a lot of other tools that do this sort of thing. You don't have to be restricted to one tool. You should be able to edit components from your IDE. You should be able to use this directly from Sketch. I think some principles, though, for a good UI builder that I've learned from working on this is component-based is really valuable because it's just simpler. If you're trying to build whole screens and whole apps in a tool, it's probably not going to come out production quality and integratable into existing apps. Similarly, if you're not Git-based, you probably can't use it in production. If you don't have an AST-level API, you probably can't configure it to work with any code base. And the cross-platform framework and language output is really important for being future-proof. Lastly, I think being open source for something like this is critical because a company has a lot of trouble adopting something that could just disappear. At least if it's open source, you can fork it if needed, you can fix critical bugs, you'd have plenty of time to get off of it if the case arose. So that's pretty much the gist. I mostly wrote this by myself, so I would love help working on it if you're interested, or help testing it or using it or whatever. It's very, very beta, but I think it's pretty awesome. So that's it.